All right, next I want to get just a little bit of practice dealing with function notation and evaluating functions. So we're going to do a few examples where we are evaluating functions for particular numbers. So let's start by defining a few functions. Let's let f of x be x cubed plus 2. Let's let g of x be the absolute value of x minus 5. We can use other letters than f to define functions. Especially if we're dealing with multiple functions, we need to name them differently so that we can tell which one is which. Let's let h of x be 3 over x minus 2. And then let's let r of x be the square root of x minus 1. So these are 4 different functions. And what we're going to do is we're going to evaluate them for particular numbers that we are given. So we're going to evaluate, let's say, f of 3 and f of negative 3. Let's look at g of 3 and g of negative 3. Let's look at h of 2 and h of negative 2. And let's look at r of 2 and r of negative 2. So we're asked to evaluate 8 different values for these functions. So let's get on and do them. The goal here is mostly to just get comfortable with function notation. So f of 3 means that we need to substitute in 3 for x. So that's going to be 3 cubed plus 2. 3 cubed plus 2. 3 cubed is 27. So that gives us 27 plus 2, which is 29. So we have found that f of 3 is 29. Good. Let's do f of negative 3. This means that we're plugging in negative 3 for x. So it's going to be negative 3 cubed plus 2. When we take a negative number and cube it, the result is going to be negative. So that's going to be negative 27 plus 2. And negative 27 plus 2 gives us negative 25. So we have learned that f of negative 3, in this case, is negative 25. All right, let's move on to g. Let's look at g of 3. It's going to be the absolute value of 3 minus 5. The absolute value of 3 is 3. So we've got 3 minus 5, which is negative 2. So g of 3 is negative 2. And then we can look at g of negative 3. It's going to be the absolute value of negative 3 minus 5. Well, the absolute value of negative 3 is also positive 3. So we get 3 minus 5, which also gives us negative 2. So g of negative 3 is also negative 2. Now, before we move on, I just want to say something. Just like we could graph an equation y equals x cubed plus 2, we can graph f of x equals x cubed plus 2. Works out the same way. Same thing is true here. Instead of y equals the absolute value of x minus 5, we could have g of x equals the absolute value minus 5. And when we have graphs, we can talk about all sorts of things like symmetry and intercepts and things like that. And it's going to turn out that this graph has some symmetry. This is symmetric about the y-axis. So even though we're talking about something that looks very different from what we were talking about before, we're talking about functions instead of symmetry, these concepts are very related. And so a lot of the things that we're looking at the beginning of the semester are going to come back. We'll be connecting them in different ways, things like that. All right, let's move on to h. we're asked to evaluate h of 2 and h of negative 2. If we plug in 2 for x, that gives us 2 minus 2 in the denominator. So that gives us 3 over 0. What is 3 divided by 0? Well, we can't divide by 0. That is undefined. So it's possible that we might be asked to evaluate a function for a particular number, and it doesn't actually work out. All right. We're going to be talking later about which numbers will work for a function and which numbers won't work for input values. And we even have a name for the numbers that do work. We call that the domain. And this is going to be something that we explore later as we get more into functions. All right, let's try negative 2. Let's evaluate h at negative 2. That's going to be 3 over negative 2 minus 2. Negative 2 minus 2 is negative 4. And that's a fine answer, but I usually like to put the negatives out front instead of in the denominator. So it looks a little bit better if we say h of negative 2 is negative 3/4. All right, hopefully you're getting used to this notation and plugging numbers in. Let's do the last ones. Let's look at r of 2 and r of negative 2. R of 2 is going to be the square root of 2 minus 1. Well, 2 minus 1 is 1, and the square root of 1 is 1. So r of 2 is equal to 1. And then we've got one last one, r of negative 2. It's going to be the square root of negative 2 minus 1, which gives us the square root of negative 3. Now you might be thinking, we've seen this before, when we've got a negative inside a radical, inside a square root, we can pull it out as an I. So you might be thinking that this is root 3i. However, we are not going to use imaginary numbers in here. There is a convention that we're going to be following for now, and you won't break it unless you major in math and maybe go to grad school. But for the functions that we're dealing with, we will only deal with real numbers. So if we end up having something where we have to evaluate the square root of a negative number, it's not possible to get an answer that's a real number. So in this situation, we will also say undefined. Some of you might have a desire, since you learned about imaginary numbers, to put an answer here, because you know there is an answer if we consider imaginary numbers. But the thing is, we're going to want to be graphing functions as we move forward. And when we're graphing, the x value here would be negative 2. So we know that's to the left 2. But the y value, root 3i, it just doesn't make sense in this context because the y-axis only has real numbers on it. It doesn't have imaginary numbers on it. So we would not be able to plot the point negative 2 comma root 3i on the xy plane. It just doesn't make sense. So whenever we have the square root of a negative number, when we're dealing with a function, we're just going to say it's undefined. All right.